Wireless network technologies. My name is Athauda and my IT number is MS18910650. Okay, this is the content what I'm going to talking about here. First one is latest version of IEEE 806.11 standard. Next one is IEEE 8.8.02.11 architecture. Next one is Mac layer of IEEE 8.2 point double one. Next one is IEEE 8.2 dot double one physical layer. Next one I'm going to talk about station problems, and next one is Bluetooth and Zigbee, RFID, hotspots, Li-Fi and wireless sensor network, and Wi-Fi channels, but on Wi-Fi controlling, WPA, WPA2 and WEP. The final one is MIMO antenna. In this slide, I am going to talk about latest version of IEEE 8.2.11 standard. First, it is 8.2.11 AC. It is Wi-Fi 5. Next one is 8.2.11n Wi-Fi 4. If you talk about Wi-Fi 5, the current home wireless routers are mostly use like 8.2.1 AC complement. It's operating 5 GHz frequency space, but in Wi-Fi 4 only allow usage to two frequencies, 2.4 GHz and 5 GHz. It can be speed up to 600 megabits per second. Next, I'm going to talk about IEEE 8.2.11 architecture. It has been divided into two parts, basic service set like BSS, and next one is extended service set ESS. Basic service set is, it is like a single access point connectivity. It can be get each other to wired network resources using wired network resources. Next one is extended service set. It is topology extended with two or more basic service set created by distributed system. Next one is the MAC of IEEE 8.2.11. Here you can see some graph like data link layer, what is the physical layer, how it has been divided into subcategories like the MAC functionalities I have been shown in the slide, point coordination function, distributed coordinate function, encryption, decryption, then what are the fragmentation and management like that way. Oh, next one is the IEEE 8.2.11 physical layer. Actually, it is IEEE 8.2.11 in 1991. It is originally defined three alternatives. First one is DSSS, FHSS, like that way. And you can see I have shown a graph. What are those model for IEEE in WLAN, MAC layer, PHI conjugates and PHI modems, mediums. Like that way we can divide physical layer into three parts. And 8.2.11 and 8.2.11 and G use OFDM orthogonal and frequency division multiplexing like that way. It is which is very different from DSSS. Next I'm going to talk about station problem. It can be divided in hidden station and exposed station. If we talk about first one, other senders information are hidden from the current sender, so that transmission as the same receiver cause collision. I have shown one of graph here to identify what is the problem here. Next one is exposed station. The sender mistakes on think the medium in is used, so that is unnecessarily defined the transmission. So the station problem of exposed station, I have been shown the what is the graph, actually using a graph the problem. Okay, next one is Bluetooth architecture. It in exchanging data over short distance, like mobile phone to mobile phone, laptop to laptop, using short wavelength radio transmission. Bluetooth is very high speed and low microwave wireless technologies designed to connect phone, laptop, PDA, etc. So it is also known as IEEE 8.2.15 standard. This one is in the bottom right hand side. You have seen the architecture design using image, colorful image, and Bluetooth can divide access code in 72 bits. Header can be divided in 54 bits, and data can be divided in 0 to 2744. Like that way we can identify here what is Bluetooth architecture and what are the usage and how is the speed through this slide. Next one is Zigbee. Zigbee is a technology standard created for control and sensor network. Actually, it is based on IEEE 8.2.15.4 standard. It is used for monitoring, control, traffic controlling, and vehicle identification problems. Like that way, we can use Zigbee for that purposes. Here you can see the graph to identify what is the Zigbee. It is integrated routers and end devices. Like that way, you can use Zigbee for traffic controlling and vehicle identification solutions. Okay, this is the architecture of the Zigbee, Bluetooth, NFC, and Wi-Fi. Here you can see frequency megahertz. What is low energy Bluetooth, Zigbee, NFC, low power. Here you can get idea what is the range for each Zigbee, Bluetooth, NFC, Wi-Fi. How is the power profile? How is node master, like that way? How many channels for each one have? Low energy Bluetooth have 3, Zigbee have 16, NFC have 1, low power Wi-Fi have 3. Like that way you can get an idea about these 4 connections information. Next one is the interest part in RFID. This is on this century is a very popular thing. RFID is technologies that use radio frequency waves to transfer data. So between radar and mobile item in identify category tracking. RFID is very fast and reliable and does not require physical size of contact between radar and scanner. So you can use for doors and controlling vehicle doors. Like that way you can use RFID to very fast and reliable devices. Next one is the hotspots. It's like Wi-Fi hotspots, the location access point where you can access wireless bandwidth using wireless enabled devices. It is refer IEEE 8.2.11. It is according to Communication Standard Wireless Network WLAN. You can make Wi-Fi hotspots and can connect many devices through the hotspots. Next one is Leafy light light-based Wi-Fi. Here you can see what is example for this. The server, internet, streaming context, and the middle one is converter, and the next one is LED lamp. It's seen. You can see at a photo detector. It is a LDR like thing. You can get the light rays. Put in a white space and black space can identify using photo detector. Next one is LED lamp can light room as well, transmit receive information, provide illumination and explain data communication. Like that way you can use Liffy to transmit data through radio waves. Next I'm going to go about wireless sensor network, where the wireless sensor network consisting specifically distributed autonomous device using sensors to cooperate to monitor physical law and environment conditions. It's a collection of sensing devices that can be communicate wirelessly. Here you can see example wire sensor network architecture. That's one is the end user, and there are so many sensor nodes and gateway sensor nodes, and you can see what are the through the graph how the wireless sensor network architecture working. Here you can see some wireless sensor network applications. Transportation logistics, what are the areas you can see: industrial application, precision agriculture, environment monitoring, entertainment, security and civilization, healthcare management, smart guiding. Like that you can see this is only some application you can find through internet. There are so many applications for the wireless sensor network. Next one is Wi-Fi channels. I can divide Wi-Fi channels into 2.4 gigahertz and 5 gigahertz. If we take about 2.4 gigahertz, its bandwidth is 100 megahertz. Like that it can be spanned from 2.4 to 2.5 gigahertz, and these are the following radio bands: and 8.211, 8.211B for radios, H.211G ERP radios. Like that you can divide 2.4 gigahertz for multiple bands, and 5 gigahertz is a transmit 5 gigahertz band, so totally 25 to 20 megahertz. It can be utilized when designing well WLAN with channel disease pattern. Like that way, that's the 2.4 gigahertz and 5 gigahertz information that have shown in my slide. Next, I'm going to look at Wi-Fi controller. Wi-Fi control is load back and load balancing and coverage holders and correction and automatic traffic redirection, and like that automatically handle the configuration of wireless access point and integrate Wi-Fi client performance tools. Like that you can get Wi-Fi controller, this kind of information. On this slide I have been shown information about WPA, WPA2 and WEP, and I have given information about the main purpose, data privacy, authentication, data integrity, then what are the key management and what are the vulnerabilities of this WEP, WPA2. And through this slide you can identify and learn the many thing about WEP and WPA and WPA and about these through these categories. Finally, I'm going to talk about MIMO antenna. It is time and frequency processing hardly meet new requirement, and this one is multiple antennas open new signal demonstration space. Through the MIMO channel, antenna create MIMO channel in higher transmission rate and higher link reliability, and it has wider coverage. Thank you.